Hello, guys. Welcome back to Maths Zone African Motives. We are still on our revisions, and this time we are going to look into our Limpopo province. Going through that, we had our March test, which is the test one, term one, 2025. All right, so we are going to look into this, all right, out of 100, 2 hours, all right. So this is, yeah, something else. You have been doing other question papers actually from other provinces. You find out it is just 1 mark. 50 marks in 1 hour, 75, but mostly there were 50 marks that we had in 1 hour. But if you look, guys, you see what is happening in Limpopo. 100 marks and it's 2 hours. So that's something else, which is good actually for students to revise a lot of questions to know their basics. All right. So that is it. You can download this question paper. Just check the description of the video or check in the comment section. You're going to see a pinned comment there. All right. So make sure you read your instructions, guys. I'm not going to waste your time. Question number one, we had questions to simplify, all right, without using a calculator on 1.1. So that was to simplify without using what? A calculator. All right, let us see what we have. The first one, that's 1.11, 9x to the exponent of minus 2 over 27x to the exponent of minus 3. All right, so here we have division of exponents. All right, so as of the numbers, guys, they are direct. You can just look for the highest common factor between 9 and 27, which is 9. So divide by 9, that's a 1. 27 divided by 9, that's a 3. But on this part where we are dealing with exponents, these bases here, which are the same, you must apply the laws of exponents. Remember, division of same bases, you subtract the exponents. So it's going to be a minus b, all right, under the same base of x. So meaning to say, this here was going to give us 1 over 3. Then our x, you are going to subtract the exponents. So that's minus 2 minus, what are we subtracting? Minus 3. All right. So this is it, guys. A minus and a minus, that's a plus. So you're going to have minus 2 plus 3, which is what? Which is 1. So that is 1 over 3x. All right. X to the exponent of 1 is what? Is x. So this is what you're going to have at the end. Okay. Those are your laws of exponents that you needed to simply apply. All right. 1.12. We are given 8 to the exponent of x times 6 to the exponent of x minus 1 over 27 to the exponent of x over 3 times 16 to the exponent of x. All right, this is very similar to the previous exam that I dealt with. All right, just try to write these numbers in a simplest form. All right, that is as prime factors. So 8 can be written as 2 to the exponent of what? Of 3. So that was going to be 2 to the exponent of 3x. Already there's an exponent x there. All right. 6 is a product of 2 and what? 3. These are the prime factors that we can multiply to obtain what? A 6. So that's 2 times 3 to the exponent of x minus 1, everything over 27, 3 to the exponent of 3, but raised to the exponent of x over 3, all right, times 16, that's 2 to the exponent of 4, raised to the exponent, times the x that was already there. So you just multiply those exponents. So that is what we were going to have at the end. And there are laws of exponents that we can use. Here, 2 times 3 raised to the exponent of x minus 1. Remember, ab to the exponent of n is going to be a to the exponent of n. b to the exponent of n. Every part is raised to the exponent that you are given. So thus, you are going to have 2 to the exponent of 3x times 2 will be raised to the given exponent, all right, which is what? X minus 1. 3 also will be raised to that exponent, which is x minus 1. Everything over what? Here, there is a law, an exponent to an exponent. X to the exponent of a to the exponent of b is going to give us x to the exponent of ab. You simply multiply the two. So here it was just going to be multiplication 3 times x over 3. That is what? That is x. So it was going to give us 3 to the exponent of x. Then 2 to the exponent of what? 4x. So this is where we are. And with our understanding here, we have got same bases under multiplication and also under a division. So we are back to, all right, it's only that I erased that, all right? So back to multiplication of same bases where you add your exponents, and if it is a division, you are going to subtract your exponents. So this is what I'm trying to say. We have the base of 2, guys. Here, if you consider properly, there is a base of 2. There is a base of 2 under a multiplication, and also this base of 2, which is under a division. So what is under a multiplication? You add the exponents, all right? So you're going to treat the base of 2 as it is, all right? So the first one to the exponent of what? 3x. Then we add to x minus 1 because these are under a multiplication. So we are going to add our exponents, x minus 1. All right. Then this one in the denominator is a division. So you're going to subtract the exponent 4x. All right. So take note of your laws. Division, where there's a division like this one in the denominator, you subtract. The same thing on 3 as a base. There is a 3. There is another one here. These are affected by what? A division. One is in the numerator, another one in the denominator. So you're going to subtract our exponents. So that's 3 to the exponent of x minus 1. Then we subtract x. All right. So you're going to subtract x, the exponent. All right. So this is where we are. We have used a law. There are laws there. All right. So simplify here, guys. This is 1. 3 plus 1, that's 4. 4 minus 4, that's a 0. So the x was going to cancel. You remain with a negative 1. So that's 2 to the exponent of negative 1 times x minus x. This is going to cancel. So you're going to remain with what? 3 to the exponent of negative 1. All right. Meaning to say, from this simplification, 2 to the exponent of negative 1, that's 1 over 2 times 1 over 3. So this is just a direct multiplication, 1 times 1 to the numerator. The denominators together, 2 times 3. That is what? That is a 6. So this was going to give us 1 over 6 at the end. All right. So direct, we can simplify in different ways and still obtain same answers at the end. All right. So just make sure you follow properly the laws. It's all about what? The laws. Follow the laws of your exponents. All right. Wherever the laws are used, you must follow that. Let us move on to 1.13. Still under our exponents you are given. That's 1.13. 0.25. All right. 0.25, guys. This is 1 over 4. All right. 25 over 100. So that's 1 over what? 1 over 4. So you can write this as 1 over 4, which is the same as 4 to the exponent of negative 1. All right. 1 over 4, which is same as 4 to the exponent of negative 1 in the base of 2 in simplest form. That's 2 to the exponent of negative 2, because 4 is 2 to the exponent of 2, but there's a minus 1. So it's going to be 2 to the exponent of negative 2. So this 0.25, guys, and 2 to the exponent of minus 2, it is just the same. So that's 2 to the exponent of minus 2 in simplest form, x to the exponent of 4, y to the exponent of 8, raised to the exponent of negative 1 over 4. So we are back to that law that I explained of a and b raised to the exponent of n, where each is raised to the exponent that we are given. So this is 2 to the exponent of minus 2 raised to the exponent of what? Minus 1 over 4. So that's 2 to the exponent of minus 2 to the exponent of minus 1 over 4. X to the exponent of 4 to the exponent of what? Negative y to the exponent of 8 to the exponent of negative 1 over 4, like that. So this is what I'm trying to say. So where we have an exponent and an exponent, remember we used this one before. I said you're going to just multiply the exponents. So that was going to be 2 to the exponent of negative cancels. 2 into 2, 1 into 4, that's a 2. So that's 1 over 2. All right. Then this is x. This one and this one cancel, so you remain with negative 1. So that's x to the exponent of negative 1. Then we have got y here. 4 into 4, that's 1. Into 8, that's a 2. So it's going to be 2 times minus 1, which is minus 2. So this is what you are going to have at the end. All right. Remember that a negative exponent, x to the exponent of negative n, is 1 over that. 1 over x to the exponent of n. So meaning to say we can get rid of those negative exponents. This is going to be 1 over x. All right. This is going to be 1 over y to the exponent of 2. All right. So take note here. We can simply multiply what is in the numerator. We multiply this. So that's 2 to the exponent of a half, which is the same as the square root of 2. Then 1 times x times y squared is x y squared. So this is what you're going to have at the end in simplest form. All right, you can just leave your answer like that, or you can just use this one as 2 to the exponent of a half. Here it is still one and the same as what? Square root of 2. So it's just a presentation, but you can just leave that one as it is. You are done. All right, you are done. Let us consider another part. 1.14, you had on 1.14 a to the exponent of minus 2, b to the exponent of minus 2, b squared minus a squared. All right. Remember what I just explained about negative exponents, so you can get rid of those. 1 over a squared minus 1 over b squared. Everything over b squared minus a squared. So this is what we're going to do. In the numerator, this is a single part that we have. So we are going to combine it to a single fraction, all right? Let us have this to a single fraction. So thus 1 over a squared minus 1 over b squared. The LCD is going to be a squared, b squared, the denominators. So let's divide. This one and this one was going to cancel. You remain with b squared times 1. That's b squared minus this one. B squared and b squared was going to cancel when you divide. So you will be left with a squared. So a squared times 1 is a squared. All right. So this is what you're going to get in the numerator by adding these two. You're going to remain with b squared minus a squared over what? A squared b squared. So this is our numerator, which is being divided to this. So you can even just write it divided to b squared minus a squared. All right, this one. This is the one that I wrote here so that we do not have confusion here. So remember, when you are dealing with a division, you must introduce a multiplication, then invert the second fraction. So this is over 1, so you just have to interchange those. So introduce multiplication, b squared minus a squared over a squared b squared times. The moment you multiply, you have to interchange that. So it's 1 over b squared minus a squared. All right, so that's it. This one and this one cancels. So this is 1, this is 1. 1 times 1, that is going to give us 1 over a squared b squared times 1. That's a squared b squared. Okay, so that is what you're going to have at the end. You are simply going to have 1 over a squared b squared. You're done. You are done. So it's just a matter of simplification, these evaluations, additions, and so forth. So it's just preparation, guys, is needed. All right, moving on to 1.2. We had an interesting question here on 1.2, the cube root of square root of 13 minus the square root of 5 raised to the exponent of 6 times the cube root of the same thing, square root, but this one is a positive, square root of 5 raised to the exponent of 6. This part that we have, we can use our surds, all right, our laws of surds. As long here, guys, we have the same presentation. This is the cube root, this is the cube root. It is the same thing as when you have square root of a times square root of b. Remember, you can multiply them under the square root. It's because we are dealing with the square root. So the same thing for a cube root and a cube root. Under a multiplication, you can maintain that and multiply those under the what? Under the cube root. So you're going to multiply the square root of 13 minus square root of 5 to the exponent of 6 to square root of 13 plus square root of 5 raised to the exponent of 6, just like that. All right, under a single cube root. So this is it. As we are under a single cube root, here we have got these two raised to the same exponent, which is 6. So what does this tell us, guys? They are raised to the same exponent 6. Remember the concept that I explained before of ab to the exponent of n, which is same as a to the exponent of n, b to the exponent of n. So this is what we have. They are being separated, but both raised to the exponent of 6. So you can write it as a single term under a product raised to that same exponent, which is 6. So I can rewrite this as what? The cube root of square root of 13 minus square root of 5, all right, times square root of 13 plus square root of 5, like this. But this whole part will be raised to the exponent of what? Of 6. From this law, it is going to be raised to the exponent of 6. It is the same. This one to the exponent of 6, this one to the exponent of 6. But we can just rewrite as a single term under a product being raised to the exponent of 6, which makes it easier for us to simplify. Why? Because there is a law which tells us that if we are given x to the exponent of m over n, it is the same as the nth root of x to the exponent of m. So meaning to say, we can rewrite this as, we take this whole part as it is, that is our x. This whole part, these two brackets, that is our x. Square root of 13 minus square root of 5 under a product times square root of 13 plus square root of 5, like this, raised to the exponent of m over n, where m is representing what? The exponent. This is our exponent 6. So it's to the exponent of 6 over n is the number that was inside the root sign. The number that is inside the root sign is what? Is 3. So this is what you are going to have at the end. But are we seeing that We have a difference of two squares here. A minus B, A plus what? Plus B. It was taken from what? A squared minus B squared. So meaning to say, if we apply our difference of two squares, it was going to be square root of 13 squared, A squared minus B squared, square root of 5 squared. But all this is being raised to the exponent of what? 6 over 3, that's a 2. Okay, we are reducing step by step. Square root of 13 squared, guys, a square root and a square neutralizes. So you're going to remain with what? 13 minus square root of 5 squared. This neutralizes. You remain with what? A 5. Everything is being raised to the exponent of 2. So this is where you are. 13 minus 5 is what? Is 8. Being raised to the exponent of 2. So that's 8 squared, which is what? Which was going to give us a 64. All right? 8 times 8. Just like that. Just like that. So many ways, guys, of evaluating. So many ways. All right, so I want you to also check with the memo. All right, you check with the memo. So many ways that you can have. Then you choose which one is easier. You can also have another way of presenting. This is maths, guys. Mathematics, you are not limited. You are not limited. So many ways of evaluating them. All right. 1.3. Simplify, all right, we had x minus 3 over x plus 3 minus x plus 3 over what? X squared minus 9. All right, let's see what is it that we must do here. If I can just try to simplify, as for me, I was just going to consider this x squared minus 9, that's a difference of two squares. So I can easily factorize that. Square root of x squared, that's x. Square root of 9, that's 3. So it's x minus 3, x plus 3. I have applied the difference of two squares, all right? Difference of two squares, dots. So thus, we can cancel here. And this is going to give us what? X minus 3 over x plus 3 minus 1 over x minus 3. So we can apply our addition, guys. All we just need here is the LCD of the denominators. That is what? X plus 3 into x minus 3. So divide, this and this was going to cancel. So you remain with x minus 3 multiplied to the numerator. So that's x minus 3 times x minus 3, which is what? X minus 3 squared. Minus, you do the same thing. This one you divide. You'll be left with what? X plus 3, which is going to multiply the one there, which is negative 1 into x plus 3. So this is the stage where you are, where you're going to expand the brackets of what? X minus 3 squared. A minus b squared is what? A squared minus 2ab plus b squared. So that is going to give us x squared minus 2ab, that's going to be minus 6x plus b squared, that's going to be 9, all right? Minus 1 times x minus x, minus 1 times 3 minus 3. Everything over our denominator as it is. So thus, we are going to collect our like terms from here. We have got minus 6x and minus x. So that was going to be x squared minus 6 minus 1, that's minus 7. So this is minus 7x. 9 minus 3, that is what? A positive 6. Everything over our denominator. So we do not know what's going to happen here. So the best way is to factorize our numerator. In case that we have got same brackets, we are going to cancel if it is like that. So we have to factorize our numerator in that case. All right, so thus since we have got the coefficient of x squared as 1, we're going to have x and x here. Then considering the factors of what? Positive 6. But these factors must add up to negative 7, all right? Products of factors of what? Of 6. That's negative 6, negative 1, 6 and 1, 3 and 2, negative 3 and negative 2. So many. But which of these, when we add, we are going to obtain what? A negative 7. That's minus 6 and minus 1. This is going to give us what? A negative 7. Minus 6, minus 1. Unfortunately, we cannot cancel anything. We do not have brackets that are the same. All right. The brackets here, they are different. So we cannot cancel when it is like this. All right. We just have to leave it as it is. This will be our final answer. All right. So this is how we can simplify, guys. Direct like that. It was 5 marks. So that's question 1. Everything 22 marks. All right, let us move on to question number 2. Solve for x. This time we are done with simplification. Now we are solving for x. 2 brackets equal to 0, guys. 3x minus 5, x plus 1, that's equal to 0. We simply have to equate each to 0. 3x minus 5 must be equal to 0, or x plus 1 is equal to 0. So that's it. Minus 5 to the other side was going to be a positive. Then divide by what? By 3. So x is going to be 5 over 3. Or x is equal to 1 to the other side is going to be a negative 1. So x is 5 over 3. Or what? Or minus 1. That is what we had on this part. It was also a little bit direct. Solve for x again on 2.2, where we are given x squared minus 3x is equal to 0. So this is just direct. X is common here. There are just 2 terms. So you can easily factor out x, which is common. So that's our highest common factor. X squared divided by x, that's our x. Minus 3x divided by x, that's minus 3, which is equal to 0. So that's from this concept, each part of this product, just like on these 2 brackets, must be equal to what? To 0. So it's either x is what? Equal to 0, or x minus 3 is equal to 0. So here we already have a solution. So minus 3 to the other side was going to be a positive 3. So these are the 2 solutions that you're going to obtain from that one, 2.2. All right, 2.3. Again, we are solving for x here on 2.3, where we are given x over 2x plus 1 is equal to 2 over what? X plus 3. All right, can we just cross multiply and see what you're going to have at the end? That's x is going to multiply x plus 3. And 2 is going to multiply 2x plus what? 2x plus 1. So that's distribute x times x, x squared, x times 3. 3x is equal to 2 times 2. That's 4x, 2 times 1, which is 2. All right, this is a quadratic equation. So definitely I'm going to need the format of our quadratic equation. Ax squared plus bx plus c is equal to 0. So meaning to say I can take these terms on the right side to the left hand side. 4x is going to be a negative. So this is going to be x squared, 3x minus 4x, which is what? Negative x. Then 2 to the other side is going to be what? A negative 2. So that's a negative 2, which is equal to 0. So as we can see, guys, we have a normal quadratic equation. You can solve this using the quadratic formula or using the factorization. You can apply factorization method. I'm just going to try factorize here. That's 1 here, so it's going to be x and x. What are the factors of what? Negative 2, which will add up to negative 1. All right, factors of -2, -2 and 1, 2 and -1. So we need out of these where we add, and we are going to have what? A -1 on these factors. That's -2 and what? -2 and 1. So that's -2 and +1. So therefore x is equal to what? -2 to there. It's going to be a positive, or x is equal to +1 to the other side is going to be a negative. It has to change the sign after that. So that is how we could have solved this equation by simply cross multiplying, expanding your brackets, collecting like terms, then having the standard form of your quadratic equation, then use any way from there, factorization, quadratic formula, anyone that you can use. 2.4, solve this to two decimal places. All right, still having a quadratic, that's a quadratic equation, 2x squared plus 7x. So let's take 2 to the other side. That will be -2 from our standard form. So once they say to two decimal places, know that they want you to apply the quadratic formula or completing of the square method. So I'm just going to use the quadratic formula. Our A is 2, B is 7, and our C is -2. So that's x is equal to minus B minus 7 plus or minus the square root of B squared. That's 7 squared minus 4 times A. Our A is 2. And our C is what? -2. Everything over 2 times A, that is 2 times 2. So meaning to say, I can just use the formula straightforward from here. I can simplify, it is up to you, but that was going to give you 0.27 to two decimal places for the positive value. For a negative, our x was going to be -3.77. All right, so guys, I've been doing this for you. Just simplify from here. Use your calculator the same way I have been applying. That is, you're going to have those answers at the end. All right. 2.5, we are given again to solve for x. X to the exponent of 2 over 3 is equal to 4. All right, so remember, these rational exponents, we're just going to need its reciprocal. All right, what is the reciprocal of what? 2 over 3. That's 3 over 2. So you multiply here the exponent by its reciprocal. Here you raise it to the exponent of what? The same reciprocal, 3 over 2. So this is going to give us what? X to the exponent of 1, which is equal to 4, to the exponent of 3 over 2 means the 2 in the root sign, so that's the square root of 4 raised to the exponent of what? Of 3. All right, 4 to the exponent of 3 is what? 64. So that is the square root of 64. Remember that the square root of any number is what? Plus or minus. So that was going to give us plus or minus 8. All right, so for a square root, do not forget the plus or minus concept, right? So many ways that you can actually apply. All right, let us consider 2.6 under our surds. All right, we are given the square root of x minus 3 minus 4 equal to 5. So remember, the first thing is to isolate the surd to make sure that the surd is on its own to make it the subject of the formula. So as we can see, what we just need is to transpose -4 to the other side of the equation. So it's going to be square root of x minus 3 is equal to 4 plus 5. Here we just need to add 4. Add 4. So 5 plus 4 is what? Is 9. All right, so this is where you are, and you need to get rid of the square root by what? Squaring both sides. So we have to square both sides of our equation. And that was going to give us square root and square cancel. So you're going to remain with x minus 3 equal to 9 squared. That is 80, 81. So to solve for x, minus 3 to the other side, that will be a positive, or simply add 3 both sides of our equation. So 81 plus 3 is what? Is 84, just like that. That is 84. So we are done. We are done when it is like this. We are done when it is like this. You do not have to test anything. It's a single value that you have. Yes, you can test and put that one, but for a single value, that's the answer that you have. It's different when you form a quadratic equation, then you need to test those two solutions. For a single solution, that will be your answer. 2.7, again, it is to solve for x. Given 9 to the exponent of x plus 9 is equal to 10 times 3 to the exponent of x. All right, let us just take this one to the other side and see what we're going to have here. That will be a negative 10 times 3 to the exponent of x plus 9 equal to 0. As we can see, this here is a disguised quadratic equation. 9 can be written in the base of 3, but that will be 3 squared raised to the exponent of x. Guys, writing this as 3 to the exponent of x raised to the exponent of 2 is still one and the same. So as we just need a format which looks the same as here, 3 to the exponent of x. So 9 to the exponent of x can be written as what? 3 to the exponent of x squared. All right, minus 10 times 3 to the exponent of x plus 9 is equal to 0. So as we can see, that's exactly a quadratic equation. The highest exponent is what? Is 2. So where we have 3 to the exponent of x, we can replace it with any constant. All right, we can introduce any constant in place of that. So using k, we are going to let k be equal to 3 to the exponent of x. So meaning to say, this will be k squared to the exponent of 2 minus 10. This is what? This is k plus 9, which is equal to 0. We are used to such type of equations than when they are exponents, but you could have just factorized there. One and the same, you could have just factorized. Anyways, let us solve for x. We're just going to factorize. Solve for k. This is k, this is k. We're going to need the products or factors of 9, which adds up to negative 10, the coefficient of k. So products of 9, this one we're not going to go further. To get a negative 10, we must have negative 9 and negative 1. All right, you multiply this, you get positive 9. You add, you get a negative 10. So that's negative 9 and negative 1. So we can solve for k from there. K is equal to what? Negative 9 to the other side will be a positive. All right, negative 1 to the other side is going to be also a positive. So that is, now we can solve for x. This was for k, but for x, we have to consider this part. Remember, k is what? 3 to the exponent of x. So if k is 3 to the exponent of x, it means k, our 9, is equal to 3 to the exponent of x, or our k, which is 1, is equal to 3 to the exponent of x. So as we have got here, x being our exponent, we can try to write these ones as same bases. 9 in the base of 3, that is 3 to the exponent of 2, is equal to 3 to the exponent of x. So as the bases are the same, it means our exponents will be the same. So therefore, x is equal to 2. Here, 1 in the base of 3 is going to be 3 to the exponent of 0. Remember, any number to the exponent of 0 is what? 1. So as the bases are the same, it means the exponents are also the same. So x is going to be equal to what? X is going to be equal to 0. So these are the two solutions that you're going to have for x. X is equal to 2, or our x is equal to 0. Yes, it can be like that. These are just your exponents. Can be direct like that. You just have to play around those typical questions like that. Moving on to another section, question number 3. 3.1, solve for x in the following inequality. All right, this is an inequality that we are given on 3.1. That's 2x squared. All right, we're going to take the 3x, guys, to the other side. Remember the format of a quadratic. So it's going to be negative 3x minus 2 is greater than or equal to 0. You'll be left with a 0 the moment we take it to the other side. So you are going to solve for x, guys, here. Find the critical values, but that can be obtained by factorizing. So I want you to factorize this part here the way that you understand, guys. There are so many ways, all right? I have been using this way of the cheat method. If you understand it, then use it. Where I said you get rid of this 2, multiply it here. So it's going to be times 2. So that will be x squared minus 3x minus 4. All right. Then you factorize as it is easier because the coefficient of x squared is what? Is 1. All right. So you're going to factorize factors of negative 4, which adds up to negative 3. That's a negative 4 and what? And 1 without wasting our time. So this is negative 4 plus 1. So you're going to bring back the 2 that we removed in place of what? In place of x. So you're going to put a 2 here. We're going to put a 2 there. Then factorize where possible in these brackets. All right. 2 here is common in the first bracket. So that's 2x and 2 is going to be x. Minus 4 and 2 is going to be minus 2. This is 2x plus 1. So this cancels. You remain with these two brackets. That's x minus what? X minus 2. 2x plus 1. That's our factorization. So, guys, that factorization, please do the way that you understand. All right. With this, we have got two brackets. So, therefore, we can obtain our critical values because critical values are obtained when we take this and equate to 0. So, it's x minus 2 is equal to 0. X will be equal to what? X will be equal to 2. Or it is 2x plus 1, which is equal to 0 in that case. So meaning to say 1 to the other side is going to be minus 1 divided by 2 by 2. So x is going to be what? A negative half. So these are the critical values that you have. So you can use your number line. You can use the graphical method to obtain the exact solutions. Using the graphical method, looking into the coefficient of x squared, that's greater than 0, so it's going to be concave up. And this is negative half here, positive 2. So our function, the whole of this, is what? Greater than 0. That is above the x-axis, or it is what? A positive above the x-axis. So this is the region above the x-axis. So therefore, our solutions will be what? On the left side of minus 2, these values are less than, minus half, All right. But there is an equal to here on our question. So you must also put that on our answer. All right. Another solution will be values on the right side of 2. This one, they are greater than what? They are greater than 2. So greater than or equal to what? 2. So that is going to be our solutions at the end. These were our solutions. You can use the number line, like I said. Still, you're going to have same answers. All right. I'm thinking I'm going to just find a time where I'm just going to explain more on number line. I've been using graphical method in answering many questions. All right. There we are given 3.2, solve for x and y for the following simultaneous equations. We have got the first equation and the second equation. So the first equation is a linear equation. The second one, a quadratic. So we are going to apply or use the substitution method, where we can make x or y the subject of the formula from our linear equation. So it was easier for us to make y the subject here. So y is equal to minus 2x to the other side is going to be what? Positive 2x minus 1. So this is going to be equation 3. Since it was from equation 1, This was equation 2. So you're going to call it equation 3. So what is that we do? We substitute that equation 3 into equation what? Into equation 2, into the second equation. All right, we made it the subject from what? Equation 1. So we're going to substitute into the second one, where you substitute in place of what? In place of y. So this is 2y squared, but y is what? 2x minus 1, but squared, plus 4xy. So this is 4xy is what? 2x minus 1. So this is equal to 6x squared. All right. So this is where you are, guys. You had to expand your brackets here. 2x minus 1 squared. You're going to use any method, or you're going to expand 2x and another 2x minus 1, 2x and 2x, 4x squared, minus 2x, minus 1 and 2x, minus 2x, minus 1 and minus 1 plus 1. Whichever way that you're going to use, you can expand that, and that was going to give us what? 4x squared minus 4x plus 1. Any way that you want, guys. Those are two brackets. You can use that a minus b squared. All right. Then here you can expand 4x to 2x. That is going to give us 8x squared. 4x times negative 1, negative 4x. All right, which is equal to 6x squared. Let us try and work out the left-hand side. 2 times 4, that will be 8x squared. 2 times negative 4, negative 8x. 2 times 1, that's a positive 2. And this remains as it is 8x squared minus 4x. Guys, why leaving this? Let us just take it to the what? To the left-hand side. It's going to be negative 6x squared equal to 0. So this is what we have. Let us just simplify at once, collecting our like terms. The part of x squared, 8x squared plus 8x squared minus 6x squared. So you're going to add and subtract 8 plus 8, that is 16. Then 16 minus 6 is going to give us what? 10. That was 10x squared. Then we move on to x. There is 8x and 4x here. So minus 8 minus 4, that's minus 12. So this is minus 12x, and 2 is just remaining as a single term as it is. All right, that's equal to 0. All right, this is where we are, guys. Remember, we need to solve for x. That's a quadratic equation. Can easily reduce this one by 2. 2 is the highest common factor. So that was going to give us 5x squared minus, this is going to give us 6x. All right, 2 into 2, that's a 1, and this is going to give us a 0. All right, so just like before, guys, you can use your quadratic formula to solve here, or you can factorize. And on factorization, use the way that you understand. All right, let me just factorize it here. All right, remove 5x squared, multiply to the constant 1. It's going to be x squared minus 6x plus 5. Then we can factorize. Here it's going to be x and x. So we need factors of what? Of 5, which will give us a negative 6. Factors of 5, which will give us a negative 6. It's negative 5 and negative 1. You multiply this, you get positive 5. You add, you get a negative 6. So that's minus 5 minus 1. Bring back the 5 that we removed before. In place of x, you're going to put a 5. You're going to put a 5. And factorize where possible. The first bracket, 5 is common. So I'm going to factor it out. 5x and 5, that's x. Minus 5 divided by 5, that's minus 1. So this one, we do not have anything common. It remains as it is. The number that you factored out, guys, is useless. Remove it. It's no longer part of your question. These brackets are the one that we need. X minus 1, 5x minus 1. And that's equal to 0. This is the one that we need. So factorize, guys, the way that you understand. Any way that you understand there. As we have these, we can solve for x. Minus 1 to the other side, that will be positive 1, or x is equal to minus 1 to the other side is going to be positive 1, but we have to divide by what? By 5. So it was going to be 1 over 5. So these are the values of x that you're going to have. But remember, that's a simultaneous equation where you must also solve for y. So how can we solve for y, guys? We can simply take it from equation 3, where y is already the subject. Y is equal to what? 2x minus 1. So it is easier for us to play around that one, equation 3, where y is equal to x minus 1. So to find y, when x is 1, just put a 1 there. 2 times 1 minus 1. So y is going to be 2 minus 1, which is what? Which is 1. Or y is equal to, when x is what? 1 over 5. That's 2 times 1 over 5 minus 1. So this was going to give us negative 3 over 5. Just use your calculator on that one. So these are the y values that you're going to have from the values of x that you had. So that is how we can simply answer this type of a question. All you just need is playing around and understanding how to solve, substitute, making this one the subject of the formula, substituting like that. All right, let us move on to 3.3. Show that the roots, all right, the roots of this equation will be real and unequal if m is greater than 0. All right, for the roots to be real and unequal, our delta is supposed to be greater than 0. All right, real and equal. Delta must be what? Greater than 0. So let's find our delta from m squared plus mx minus 12 is equal to 0. All right, this was wrongly written, sorry. Here it was just a mistake, like the question was wrongly written. It was supposed to be mx squared plus mx minus 12 is equal to 0, all right? So taking from our quadratic equation, A, B, C. So our A is m, our B is m, our C is what? Minus 12. So we need our delta, which is b squared minus 4ac, remember? So we can prove, is it going to be greater than 0? So that's it. So b, that's m, so which going to be m squared minus 4 times a. Our a is m, and our c is what? Negative 12. So that was going to be m squared minus 4 times minus 12. That's positive 48m. So this is where we are. Yes, we can factor out, or we can even justify from here, or you can factor out m, which is common. This will be m plus 48. Guys, we are told that m is what? If m is greater than 0. So if m is greater than 0, like what we are told here, this number is a positive, it is greater than 0. So what about m plus 48? Obvious also is going to be greater than 0, guys. We are adding 48 to a number which is already greater than 0. So definitely we're going to have what? M plus 48 being greater than 0. So therefore, it means our delta, guys, is greater than 0, because this is positive. This is also positive. So our delta is what? Is greater than 0. If delta is greater than 0, it means our roots are what? Real and unequal. Real and what? Real and unequal. So that is the concept that we had to prove from the m that we are given. It's a value that is greater than 0. So therefore, delta is also going to be greater than 0. All right. So that was it on question number 3. All right. All right. Let us move on. Question number 4. This is part of our trigonometry. All right. 4.1. If theta is a reflex angle is the one that is greater than 180 degrees, but less than 360 degrees. So they are actually giving us the value of theta to say it is found within this interval. And tan theta is what? Negative 3 over 4. Determine with the use of a calculator and with the aid of a diagram the value of these, all right? Let us have our diagram first. Since we are told that the angle that we are dealing with is a reflex angle greater than 180, but less than what? 360. So it means it is found between the third and the fourth quadrant. That is where our diagram is supposed to be. But in the third and what? Fourth quadrant, where is it that tan is a negative from our cast concept? All right, from our cast concept. Tan is positive in the third. It is negative in the fourth quadrant. That is the quadrant for cos. So tan is negative. So our answer is supposed to be in the what? In the fourth quadrant. That is where we are supposed to have our triangle drawn. Tan is negative in the what? In the fourth quadrant. All right. So that is where we are going to have our triangle. And according to this, thus we are given as negative 3 over 4. Remember tan from the Soccer concept. Tan is opposite over adjacent. So we've got opposite over adjacent. So according to this is our opposite, negative 3. Our adjacent is what? Positive 4. So you can find the third side representing the hypotenuse, which is r there. So r is the square root of x squared plus y squared. So that was going to be square root of x 4 squared plus y squared minus 3 squared. So that's the square root of 16 plus 9, square root of 25, which is going to be 5. All right, hypotenuse is always positive. There's no plus or minus for what? For hypotenuse, all right? So this was our diagram. So we can answer the questions now that we are given here. 4.11, the sine of theta according to our ratio is opposite over what? Over hypotenuse. Opposite over the hypotenuse. So what is the opposite here? Negative 3. That is the opposite according to the angle here. Negative what? Negative 3. So we have negative 3 over hypotenuse, which is what? Which is 5. 4.12, cos of 180 degrees minus theta. From our reduction, we need to reduce this. Remember, 180 degrees minus theta is found in the second quadrant, which is the quadrant of a sine. So cos is what? Is negative. So this was going to give us negative cos theta. So that's negative. What is our cos? Adjacent over hypotenuse. So you're going to need negative cos adjacent. Our adjacent is 4. Our hypotenuse is what? 5. So that's 4 over what? 4 over 5, which was going to give us negative 4 over 5 at the end. So that is how we can play around with this. All right, you are done. Then 4.2, we are given sine of 17 degrees is equal to A. All right, this one you can just draw a normal right angled triangle. All right, you can just work it from a normal right angled triangle, guys. All right, so you're given that the sine of 17 degrees, let's say this is 17 degrees, is equal to A. So A is same as what? A over 1. Remember, sine opposite over hypotenuse. So this is our opposite, A. Hypotenuse is 1. So you're then forced to determine the third side. All right, so this third side is going to be 1 squared minus A squared, which is 1 minus A squared. Then you introduce the square root. So that's square root of 1 minus A squared. All right, so determine or calculate without using a calculator. You must express the following in terms of A. 4.21 tan 17. The tan of 17 degrees. Remember, tan from our soccer tour, opposite over adjacent. So this is our opposite and this is our adjacent. So it was going to be A over the adjacent 1 minus A squared, the square root of 1 minus what? 1 minus a squared. All right, that is tan 17. All right, moving on to 4.22. That's the sine of 107 degrees. 107 degrees. All right, we can reduce this one, guys. Remember, 107 lies between 90 and 180. This is the quadrant of 180 degrees minus theta or minus x. So we can write it as the sine of 180 degrees minus the acute angle. Which acute angle? To get 107. Let's subtract that from 180, 107. So that's 73 degrees. So this lies in the second quadrant from our cast concept. It is the quadrant of a sine. So that's a positive sine of the acute angle. Our acute angle is what? 73 degrees. So this is sine 73 degrees. Do we have 73 degrees in this triangle? All right. Remember, these two angles are supposed to give us what? 90 degrees. So you can test that. 90 minus 17 is 73. So through this remaining angle is what? 73 degrees. So the sine can be obtained because sine is opposite over hypotenuse from our soccer tower. Opposite over hypotenuse. So our opposite is what? The square root of 1 minus a squared over the hypotenuse, which is 1, according to 73 degrees. The opposite is now the angle that you are facing. So this is the same as what? Square root of 1 minus a squared. As we are dividing by 1, guys, it just remains as it is. All right, so that is the sine of 107. It was going to end up like that. All right, let us move on. 4.23 cos squared 253. 253 will be in the third quadrant, and this is 180 degrees plus theta. So it was going to be something like cos 180 degrees plus what? To get 253, it's going to be 253 minus 180, which is 73. So that's plus 73 degrees. But it is being what? It is being squared plus the sine of 553. This is more than 360. So you must subtract 360 from that. 557 minus 360 is 197. So this was same as sine squared 197. 197 lies also in the third quadrant, 180 plus theta. So it was going to be sine of 180 degrees plus what? To get 197. So that's simply 197 minus 180, which is what? 17. So it's plus 17 degrees. But do not forget that it is what? It is being squared. The whole of this part is being squared. So let us reduce now. Cos 180 plus 73 degrees. This is in the third quadrant, the quadrant for tan. So definitely cos is what? A negative. So it was going to give us a negative cos of what? The acute angle, 73 degrees. All right, being what? Being squared plus sine 180 plus 17 degrees, also 180 plus. It is the third quadrant for tan. So sine is what? Is a negative. So you're going to reduce this and write it as negative sine of what? The acute angle, our theta, 17 degrees, being what? Being squared. So this is where we are. We can determine these values because we have them on our triangle 73 and what? 17. So the cos of 73, cos adjacent over hypotenuse. So according to 73 degrees, according to 73, our adjacent is what? Is A. So that's adjacent over hypotenuse. So that's A over what? A over 1. Adjacent over hypotenuse. Plus the sine of 17 degrees. Remember, sine 17 is the one that we're already given. Sine 17 is equal to what? Is equal to A. So in place of that, I'm gonna put a, so it's minus a, minus sine 17, but sine 17 is what? Is a. So it was gonna be a squared. All right, negative a over 1, guys, is same as negative a. So here it is same as negative a, but we are squaring it. So it's gonna be positive a squared. You square a negative, it turns to a positive. So this is where you are. A squared plus a squared, this is 1, this is 1. So 1 plus 1 is what? Is 2. So that's 2a squared. Just like that. So this was going to give us 2a squared at the end after simplifying. So you see, guys, somehow you have to play around with questions, understand your diagrams and so on. But it's just interesting questions that you have that you just need to open up your mind and understand all the basics as you have them in your syllabus. You just have to work all the basics. So if we check our question number 5.1, we are being asked to simplify the following fully without the use of a calculator. All right. Thus, firstly, we have cos minus 225. All right, this is a negative angle that you have. So remember, negative angles are taken as minus theta, theta minus 180, minus theta minus 180, or minus 180 minus theta, theta minus 360 degrees. So if you check, we are taking our angles going this way. So that will be something like 0 degrees, minus 90, minus 180, minus 270, and so on. So minus 225 is in between minus 180 and what? Minus 270. So those angles are written as minus 180 minus the theta, the acute angle. So we are going to rewrite that as cos minus 180 minus theta. So to get minus 225, we must have this 225 minus 180. So that's minus 45. Minus 180 minus 45 gives us minus 225, all right? Sine 135, these are positive angles. Remember, positive angles, this is theta, 180 degrees minus theta, 180 degrees plus theta, 360 degrees minus theta. So we count them going this side, and that's 0, 90, 180, 270, 360. So 225, 135 is between 90 and 180 in the what? Second quadrant. 180 degrees minus theta. So it must be sine 180 degrees minus theta, the acute angle, to give us what? 135. So that's 180 minus 135, which is what? 45 degrees. So that's 45 times sine 330 between 270 and 360. So those are written, all right, this is actually plus. Here we are to add plus, all right? So that is going to be sine 360 degrees minus theta. To get 330, you're going to subtract 30 degrees here, all right? So everything over tan 225. 225 is in the third quadrant, 180 to 270. So those angles must be 180 plus theta, the acute angle. So that was the concept. Tan 180 degrees plus what? Plus theta. So which angle are you going to add to get 225? It's what? 45 degrees. So that's it. We can reduce them in terms of their corresponding acute angles. These acute angles, this represents the same thing as theta. This one, theta, theta. All right, same thing as where you have got the part of theta. So where we have 180, minus 180 degrees minus theta, it lies in the second quadrant, and that is the quadrant for what? for a sine. So cos is what? Negative there. So it's going to be negative cos of the acute angle, 45 degrees, times sine 180 degrees minus 45. It is in the second quadrant, 180 degrees minus theta. So that is the quadrant for what? Sine. Sine is positive there. So that's sine of what? 45 degrees as a positive. All right, plus here it is sine 360 degrees minus 30 in the fourth quadrant. Then that is for cos. So sine is what? Negative. So that's negative sine of 30 degrees. Everything over what? The tan of 180 degrees plus 45. This is 180 plus theta in the third quadrant, and that's for tan. So tan is going to be positive. So that's tan 45, all right? Just like that. So we can simplify further. Remember from our special angles, guys, as you are told not to use calculator, for 45 degrees. Yes, you can even just use your calculator. No one is going to know, guys. 45, 45. This is 1, 1, square root of 2. Remember that cos 45 and sine 45, they are the same. Cos 45 and what? Sine 45 degrees are the same. That's opposite over hypotenuse or adjacent over hypotenuse, which is going to be 1 over square root of 2. This is the same as what? Square root of 2 over 2 when you rationalize. So meaning to say, it was going to be minus cos 45 square root of 2 over 2 times sine 45, which is the same, square root of 2 over 2. All right? Plus and minus, that's a minus. So we need sine 30 from this triangle. It is what? 1, 2, square root of 3. So sine 30 opposite over hypotenuse is what? 1 over 2. So that's 1 over 2. Tan 45, according to tan, it's opposite over adjacent. So 1 over 1 is going to be 1. So tan 45 is what? Is 1. So this is where we are. We can simplify, guys. Multiply here. Negative square root of 2 times square root of 2 is what? Is 2. Remember that square root of a times the square root of a gives us a. So when you multiply square root of 2 and square root of 2, you're going to get 2 over what? 2 times 2, that's a 4, minus 1 over 2. This is over 1, guys. You can just ignore that one. Minus 2 over 4 is same as 1 over 2. So that's minus 1 over 2 minus 1 over 2. The denominators are the same, so simply subtract the numerators. Minus 1, that's what? Minus 2 over 2. And that was going to cancel and give us a negative 1 at the end. All right, so that was it. Under our simplification, it was just going to give us a negative 1. All right, let us see another part of our question. This was it. Your special angles can be used. But where they apply the special angles, even if you use your calculator, guys, no one is going to know that you have used a calculator on that part. All right. Anyways, let us see. 5.2 sine 180 degrees minus a. We can reduce this one. 180 degrees minus theta in the second quadrant, and sine is what? Positive there. So that's sine of a times tan of what? Of a times sine 90 degrees plus a. These are from our core functions, but this one, it will lie in the second quadrant. So remember, sine is positive there. So it's going to give us a positive cos. Remember, core functions, sine changes to cos. But as sine is positive, it means the corresponding acute, the corresponding trig that you're going to have for cos, having this acute angle A is going to be positive as well. All right. Tan 180 degrees plus, this is the third quadrant, which is for tan. So tan is what? Positive. All right. Times the sine of minus a. Minus a, that's a negative angle. Minus theta, which lies in the what? Fourth quadrant. And there, sine is a negative. So it was going to be times negative sine of A. Cos minus A, guys, we are still having a negative angle in the fourth quadrant, and that's for cos. Cos is positive in the fourth quadrant, so it was going to remain as a positive. That's positive cos of A like this. All right. Anyways, guys, we can see here it was just a matter of canceling. These are the same. Sine A and sine A cancels. Cos A and cos A, tan A and tan A. So it was going to give us 1 in the numerator. In the denominator, do not forget that there's a negative here, so it's going to be negative 1. 1 over minus 1 is what? Negative 1. All right? Oh, the same answer, just like this one, it gave us negative 1. Anyways, it can happen. It can happen. What can you do, guys? You just have to leave your answers as they are. Number 6, prove that this identity here is the same. All right. How can we prove that? 6.1. So I'm going to take the left-hand side. That's complicated. Sine of x plus cos of x squared. Remember from our a plus b squared, which gives us a squared plus 2ab plus b squared. So it's going to be sine squared of x plus 2ab, that's 2 sine x cos x plus b squared, the last term, which is what? Cos squared of x. So are we seeing that sine squared and cos squared, this gives us a 1. That's our Pythagorean identity, this one, which we know that it gives us what? It is equivalent to 1. The whole of this part here is equivalent to 1. So it was going to be 1 plus 2 sine x cos x. Isn't it the one that you're being asked? Yes, it is the one exactly, or as it is on our right-hand side. So you have proved. You have proved, guys. Do not fight. Do not fight. Just prove like that. You're done. You move on to another question. Given this, prove on 6.21 that it is the same. Prove that given identity. So I'm going to take the left-hand side. Thus, sine x over what? 1 plus cos of x plus the cos of x over the sine of x is supposed to give us 1 over sine x. All right, no problem. Let us add these two. I'm going to have the LCM or the LCD. 1 plus cos x times the sine of x. So let's divide this, and this is going to cancel. So you remain with sine. So sine times sine is what? Sine squared. Sine squared x plus these two will cancel. So you're going to multiply this to cos of x. So that's cos of x times 1 plus cos of x. So let us expand our brackets. Sine squared x plus cos x times 1, that's cos of x. Cos times cos, that is going to give us cos squared. Cos squared of x, everything over 1 plus cos of x times the sine of x. Guys, are we seeing that we are back again to that Pythagorean sine squared, cos squared? The sine squared plus the cos squared of x. We know that it must give us what? Supposed to give us a 1. So this is 1 plus cos of x. Everything over 1 plus cos x times the sine of x. So guys, this is the same as we have got a single term. So we're going to divide, that's 1, and this is 1. So you're going to have 1 over what? Sine of x. And this is exactly as it is on our right-hand side. So this is 1 over sine of x. We have managed to prove that one. And therefore, they want us to for what values of x in the interval from 0 to 360 degrees will the identity be what? Undefined. A over b to be undefined, it means b is equal to 0. So this identity, when we proved it, we proved that it is the same as what? 1 over sine x. So we can use that single fraction that we have and work with the denominator. It must be equal to 0 for us to have what? an identity that is undefined. So our denominator sine of what? Of x must be equal to 0. All right. So thus you can have your angles from there that gives us 0. That arc sine of what? Arc sine of 0 here. Arc sine of 0 is 0. So it will be difficult for you to actually know the angles that will give us a 0. All right. It will be difficult for us to know because we've got 0 degrees. Guys, where do we put 0 degrees? And which quadrant can you say that is where we have 0 degrees? So for this, you try special angles 0, 90, 180, 270 up to 360 degrees. Those angles that we have on our quadrant. So those are the angles that you use to test for the values of x. You know that the first one, yes, it is 0 degrees. Or you move on to another one, 90 degrees, and see if it is going to give you a 0. Sine 90 is what? 1. That's not a 0. So we move on to 180, sine 180, that's a 0. So meaning to say 180 is also part of our angles. You move on to 270 degrees, do the same, 270, that's minus 1, not a 0. We move on to 360 degrees, that's a 0. All right, 360 degrees, that's a 0. So also it is part of our solution. These angles, when you put them on x, you are going to have a 0. Sine 0, sine 180, sine 360 degrees. These are the angles which will give us a 0 at the end. So those are the values of x from 0 to 360 degrees. All right, so as we can see, yeah, that's an interesting, it was an interesting question paper. It was an interesting test. Had a lot of things to recap and to work with. As an individual, you can see that you had to go through all the basics. They wanted you to revise all the basics, which is a 5-star rating to this Limpopo province. That is good. Students can actually go through all the basics in their syllabus in March, as soon as March. Do not wait for June exams. Do not wait for those trials and so on. Now, start to revise now. Mathematics is every day until you are done. Every day. All right? So please do revise as much as you can. So that is it till we meet again.